I'm Hike, so I have been at Skydio for something like 8.5 years. I was one of the first employees. I'm now the manager of the Autonomy team, so just worked on a lot of different parts of the engineering system. So I'm not sales, I'm not go-to-market. You're kind of getting it direct. I can't answer some of the questions you're going to ask, probably, but I'll do my best. And overall, I'm going to try to skip the stuff that we covered in the keynote, not try to be marketing, and just kind of maybe go one level deeper and talk about some of the technical pieces, show some visualizations. Feel free to honestly ask questions whenever, direct me to whatever is interesting. Game to talk about it. I think overall, I want to give a sense that we have a team that's just working really hard every day to try to make stuff better for your use cases, listen to what you're saying. I think in some ways, a lot of you are more optimistic than the engineers on our team because they spend all their time looking at stuff that's not working. And so we definitely don't think we're perfect. We're doing our best to really try to make it work and find out how to build and grow in the right ways. So let's get into it. The kind of generation 3 autonomy that I kind of mentioned is really more about the right side of this platform. So we have this hardware platform that has the compute, it has the cameras. We think this is just a really awesome canvas to do robotics and make the robot do things for a bunch of different use cases, be intelligent, trustworthy, safe, efficient. And the navigation engine is the core thing that makes the robot maneuver, know where it is, not crash. That's kind of the baseline. And as I mentioned in the keynote, really, we're putting a lot of our focus on the stuff that lives above that, that's going a level beyond, it's hard to crash, and goes to, we have a new workflow. And so that's the stuff I'm going to kind of maybe deep dive a little more today. So yeah, really, X10's great. You should all get it. Lots of compute power. I mentioned this. So here, I think maybe one thing to just call out is as these processors are advancing, there's a lot of details that start coming in where the computer is not just one big processor and you can do whatever you want. People are building, in this case, people being NVIDIA and Qualcomm are building a lot of accelerators for different tasks. They have accelerators for video processing, they have accelerators for neural networks, they have accelerators for low-level signal stuff. And so it's not, you kind of get more and more specialized, and we're not using all of the compute power that's available today. I think there's a lot of room to go in how we specialize our algorithms, how we make it faster, and it's just more heterogeneous, the computing space, because the processors are getting more and more specialized, which makes them more power efficient and faster and stronger. So yeah, talked about the nav cameras. I'll largely skip that. I think an interesting graphic here is just to get a sense of when I say 10 times the number of pixels that get processed, like that's what that means, the difference between the shapes of those two images, and that makes a big difference. Skip over this, but we heard a lot about the sensors today. I think just in terms of the autonomy, you can build a lot on top of powerful cameras. Like that's the primary input, and so the better sensors we have, the more we can do with that. So very fun playground for us to build on this hardware platform. All right, so navigation engine, I think, again, we're kind of known for this already. There's not a ton here I need to go in detail into. I think one piece that's interesting is that more and more the ability to fly in GPS-denied environments, not just indoors, but kind of high up in the air, and especially in cases where you might have the electronic warfare and so on, that's an increasing importance. So we're looking a lot on different options for enabling that kind of thing where you have GPS jamming, essentially. So the vision is super powerful, and we've worked for the entire life of Skydio to make the most out of cameras. And the sensors are very cheap. They're made in the billions for cell phones. They're very powerful. But there's a lot of difficulties with them that we have to tackle. And this is just a good highlight of some of those things. So you get effects like really bright sun glare. You get, when you're flying low over water, the water it's not really like a static scene. It's reflective. It moves. It's confusing for the algorithms. You get thin branches, obviously, thin cables, the notorious enemies of the drone. You can have environments where it's really hard to see anything with the scene texture and run algorithms. You might be in a desert. You might be in a room with just white ceilings and walls, and being able to tell the difference between, is that a gray sky or is that a wall? It's not an easy thing to do. So snow, dirt, dust, cracks on the lenses, really low light scenarios. Like there's all kinds of edge cases that we just encounter and try to figure out the best ways to tackle. But our bet is certainly on vision here. So for obstacle avoidance, not to toot the horn too much, but this is like one of our deepest investment areas. So we were the first product, period, not just drone, to use deep learning for obstacle avoidance. And we did this because it means it can learn from data. And that's just that's the core bread and butter of our drones. That's kind of the starting point. And so I just want to highlight, I mentioned the new architecture we have on the new generation drones. I just want to highlight an interesting scene here and some of the factors that are in play that make this stuff hard. So here we're in some kind of substation scene, and there's a bunch of thin stuff, and there's also a sun that's kind of shining through. So these effects where the sun is suddenly very bright causes glare. The glare looks different between the different cameras. It's a very challenging thing because if you take those different pieces of glare and you match them between the cameras, you'll get some bogus crap. And the drone will see that bogus crap, it'll swerve around, it'll be confusing. And we have, even the sky is kind of interesting to comment on because there's no texture in the sky. So you can't just match the texture between the cameras and figure out what's the sky. You have to use kind of a smarter deep network that's actually learning to predict the sky. And another interesting thing is there's two actually drones flying in this scene. One's there and one is up there. And so we see some fun bits and pieces of that, but don't try to crash two drones together because that's not covered under warranty. A fun fact, so internally, this is purely internal name, but we call this the Scorpion model, which I think is a fun. We like to give animal names to our pieces of our autonomy system. Okay, so tracking stuff. So I think most people have seen Skydio's history. Has kind of had a ton of cinematic tracking. We're low, someone's skiing, we're filming them from the front. I think with the X10 and with your kind of use cases, we're really focused on longer range tracking, giving effective situational awareness, and making the mental load easier for the pilots. So a ton of work is going into this in all sorts of domains, and I think we covered a good amount of this in the keynote. From the kind of vehicle propulsion and control side, we actually have a brand new kind of next generation control stack. Again, internal name, we call it Air Dragon. So here, really everything from the high level kind of motion planning optimization down to the lowest level motor controllers are new and custom. And these are some footage of flying in a wind tunnel, which is fun. The right side video it's just like it shows really the stability that we're trying to get and optimize for. And so actually the lowest level motor controllers doesn't seem like something we would have to make ourselves, but for getting maximum efficiency and robustness for stuff like if you have big wind gusts, if something hits a propeller, for maximizing battery life, we went in and we replaced the firmware that comes on these existing motor controllers. And this is something that's running at 30,000 times per second. So it's really, really low level code that controls the voltage of the motors and the electromagnets. All right. We covered a lot about night sense. It's one of the most fun things, for sure. What should I call out? So this is a fun video. This is the visible light equivalent, and the light's kind of sort of blown out on the cell phone video I took, so it's a bit extreme, but you can see the fun UFO effect. It's great UFO fodder. And of course, the infrared one is invisible, but just the basic idea, like that's what's happening. The drone is lighting up all around it, and then we're using visual perception and invested in a bunch of algorithmic improvements to handle this for visual navigation. So this is really like, here's what the drone is seeing with the normal camera. That's what it looks like to a human with the infrared attachment. Here's what the drone is seeing through its infrared navigation cameras. And then, of course, we're building 3D maps, avoiding obstacles, all that good stuff from that view. And this is another fun one where we're actually, this is actually doing a kind of a keyframe motion through these trees. And you can see more of a 360 view on the right as we're moving through it. So some of the challenges, there's a lot that come with the hardware and the lighting and everything, all that. But on the algorithmic side, so these effects where you're surprised how much dust and particles are in the air until you start looking at these cameras flying in dark where you're lighting up. And this is a major effect that just we had to do a lot of adaptation of our deep networks to handle and basically ignore. It's kind of in the realm of we have to ignore the sun glare, we have to ignore dirt and dust on the lenses, and just kind of learn how to handle some of these things. And lighting is really challenging because there's just all kinds of different effects that happen. You might have a bright light somewhere and be very dark in the other parts of the scene. Here, there's a particular stop sign that's retroreflective. It just looks pure white. So there's a lot of just challenging edge cases that happen. And then another really important piece is, you're lighting up a scene, and then you fly away, and there's nothing to light up anymore, and it goes all black. What do you do at that point? Well, hopefully, you switch to GPS. But you don't always have GPS, maybe, and so how do you handle that? How do you handle the transitions? If you're under a bridge, over water, you fly out, those kinds of trade-offs are really tricky, and you can have a lot of tough edge cases. So we dived in really deep here to try to figure those things out. All right, so moving on. Talked about 3D scan. It's awesome. The basic premise, I think most people here are familiar with it. You make a volume, the drone explores it, builds a tailor-made plan, captures a data set, tries to be hands-off. So onboard modeling, I talked about it, builds a model for you after the flight on the drone, no internet needed, no uploading of data, gives you good insights on the spot. And under the hood here, so we have, computer vision technology is kind of the core thing we do on our team. And a piece of this is kind of photogrammetry where we're building 3D models. And this happens in a lot of ways, right? It happens for obstacle avoidance where we really don't care about high precision details. We're just trying to not hit something, to all the way to something where a photogrammetry provider might build a really detailed model. And we kind of do everything in between, where whether it's in flight, whether it's on the drone after flight, we have different levels of kind of precision that try to reuse our deep networks and techniques that can kind of scale to how much compute do you want to use, to how much quality you want to get, what are you optimizing for. So there's a lot of pieces here that we've kind of worked on, and the onboard modeling is kind of this in-between, where we think the model is quite good, we think it's useful, it's not the same level of detail as you're going to get from an offline photogrammetry provider that takes a long time to process. So we're kind of trying to strike that balance here. All right, so we do one of my favorite sequences here. I'm just talking about starting from the VPS and talking about some of what that means for how we see these new workflows with the drones. So the basics of the VPS is that, so on the top right, you take some site, like somewhere you're going to fly multiple times, like any one of your facilities, indoor, outdoor, whatever, and you fly the drone around, and we're basically able to build a map of it. We can remember that map, we can upload it to our cloud, and then when you want to fly a mission again, we will localize against that map. So we have the map from the previous flight, and then you're kind of matching against it as you fly. That's kind of the basic premise, and you get localization. So you don't drift. Right? So let's take that, what you can do with it. So you can capture repeated photos of something. This is just a fun time lapse of every 30 minutes for 24 hours we did a flight. We took a picture of this clock. And actually we're now bothered by the fact that this is shifting. This is from more than half a year ago, so we're trying to do better. You can fly kind of repeated missions. This is in a dock context, but through a narrow doorway, we're localizing, we're avoiding drift. And that won't work without VPS. If you're just doing the visual estimation, you'll drift, you'll get stuck in the door. You'll think the door is somewhere where it's not. Now, what you can do, you take your facility, you go explore it with the drone, and it builds up a map. And then we can build a textured mesh of the facility using the navigation camera. So it's a bit different than onboard modeling, which used the subject camera from a 3D scan. Here we're using the surround cameras to build a model. And then you get this sort of textured mesh of your facility. Okay, so here's kind of building up this model. We're flying around the facility. And then after we're done with that, boom, we get a cool mesh. Now that we have this asset, we have a VPS map, and we have this kind of nav camera mesh. And we can do all sorts of fun stuff with that for your facility. Right? So now you've mapped the area. The drone knows how to get from anywhere to anywhere. Kind of that's the, if you have this room to this room down here, the drone knows what's open, how to get there. Obviously, things change. There could be obstructions, but that's kind of the core promise of the system. So now, again, I'm not showing production stuff. I'm giving you tech ideas of what we have. But you can here fly around like it's basically GTA 6. So you're in a video game, and you can click somewhere for the drone to fly, and the drone will go there, and this is actually a third-person view. So the first-person view is on the top. You're looking at the 3D model here, and you're really interacting with the drone in this space in your web browser. And so you could imagine you have multiple drones. You could imagine you have interesting things in the scene, and you're just kind of making the drone this kind of intelligent agent that knows how to get places, and it's just going a higher level than you're controlling the drone as a pilot. So now I want to go a step further and just talk about something that is, we think, really powerful. So now you have this site, you have your facility, and most of you have prior data about your facilities. So whether it's, here we're showing in a warehouse context, this is actually our manufacturing warehouse, but it could be outdoors at your substation, like where your assets are in the scene. You probably have CAD data, you have some kind of manifest of what's where, and we want to make it so you can import that kind of data and kind of line it up with this 3D VPS map that we've built. Then hopefully that gets ideas going for what you could do with that, because now you can say, okay, there's this structure over here that comes from my data, I have an ID for it, and I want the drone to go over here and do an inspection of it. Or I just want some photos of this, there's a gas gauge here, check it by name, and send off a mission to do this. So we think this is going to be a really powerful way to just make it so that you have a read on the facility, everything in it, and how to control the drone to do things within that ecosystem. So for example, you could take a bunch of these imported, in this case, racks of our warehouse and generate a mission plan that has a bunch of waypoints to go inspect that, say for inventory purposes. You could see in 3D, you can modify these, you can kick off a mission, you can schedule it to run when you want to. And then something that is in level beyond that is then we actually can take where those structures are and label them in the photo so that you can take later, you can take that information and align it to different detections that you have. So for example, this is a simulated view of a waypoint where the drone would take a photo. And then these are the structures that were imported for our manufacturing warehouse. Over here is the real view of taking a photo from that waypoint. And then these are actually polygons that show where we thought the specific structures are. So this would be aisle 1, 2, 3, 4, 5, 6. And so if you detect, say, a code right here, you could say this code belongs to this shelf and stuff like that. So you can imagine flying over a substation and you're doing a scan, and then you know where all your structures are, and they're labeled in an image, and you can pull them off with an API and do useful stuff. So this is new stuff, and I think it'd be really interesting if you all have ideas for kind of how this could apply to your industry or use case for us to hear about it and just think about how, what direction to take it. So yeah, that's kind of the, spatial AI and a lot of stuff around that. Where like you have a facility, you know what's in it, you can build maps, you can control the geometry of the drone, and now, I talked about this in the keynote. The semantic AI is really more about the what. So we talked about a lot of this geometric stuff. Now, for the drone to understand what is the purpose of things, that's where this kind of foundational AI comes in, and it will work super well with everything that we just looked at before as the vision kind of comes together. So we're seeing just some crazy breakthrough progress in large language models, but also visual understanding models. And because of the compute on the X10, as I said in the keynote, we can leverage a lot of that stuff to really make our drones understand what they're looking at. And one of the big promises of this is these models can be trained on really large kind of internet scale data and then have a pretty general purpose understanding of the contents of images where you can rapidly adapt to tasks from a smaller number of examples. So this means is like, imagine you have a skilled human pilot that's doing something, and you tell them, all right, look, like here's how you inspect this object. Here's how we look at this junction or something, and you train them for a couple days. Then they can remember that, even from a few examples, and they can remember and repeat it. So that's the kind of thing where there aren't a bunch of pictures on the internet of the important defects on a bridge or something, but if you can use these large deep networks that have a really good understanding of the general space of images, and then you can adapt them to understand this is what a junction on a electrical piece of equipment is, or this is what a crack in a bridge surface looks like, and it can quickly learn from a small number of examples what that is, then that's super powerful because it means our drones can adapt to a bunch of domain-specific tasks. So that's kind of our goal. That's what we're investing in, is being able to then go into all your industries and try to figure out how can we make it so our drones will learn and understand what is your domain, what does it mean. And there's just a lot of different tasks to adapt that to. It's not just detecting a crack. There's everything from kind of semantically searching images to writing descriptions to looking for arbitrary objects to looking for outliers. There's just a lot of different ways to adapt these models, and the technology is getting really good for adapting these large deep networks for specialized tasks. And that's just super, super exciting for us. So I mentioned the scanning piece. This is a specific piece we're working on that is also super interesting to hear from you all about, where if the drone is inspecting something with 3D scan, instead of taking thousands of photos, let's figure out the 10 objects you care about for your structure type. We'll zoom in, maybe with that telephoto lens, take photos of that, we'll label them for what it is, organize it for you, and instead of getting thousands of photos in a long time, you get a quick shot list, hopefully what matters, and it's much, much faster. So we've seen that as like a key thing for just scaling up to, when you have thousands of assets and 3D scan just does not make sense today. Maybe you're not trying to build detailed 3D models of your transmission tower or whatever else. So yeah, I also introduced this. I think obviously this is kind of a far-reaching idea of just the drone is your teammate, your partner. You can communicate with it. It sort of seems both kind of like I didn't want to define it specifically to what it is and add a picture in there, because I think it really just whether it's useful, the way it would be useful, really depends on feedback from you all, and we don't have anything that specific yet. It feels like a big part of the future where the drone will really like learn, understand, you can communicate with it, and the way you would with a teammate that you're working with. So again, really excited about ideas, concepts here of what would be useful, what is kind of pointless, and there's a lot of trade-offs. And so that's kind of my pitch here, is that we see a technology path. We're really excited about all the foundational, both spatial and semantic kind of understanding, the AI, all this technology ecosystem with the drones and the cameras and the docks and that whole ecosystem working together. But we want to figure out what are the most exciting, promising use cases where we can have the most impact, and just love to work with you all on that in the ways that it makes sense. So yeah, I didn't talk much about the dock, but that kind of takes everything we talked about and supercharges it, because you can then not have a person on site. You can build these facility maps, you can schedule missions, and you can do all of this across many facilities, right? Like that's the ultimate vision of Skydio. Yeah, and just to mention, I think you all were at this warehouse or will be tomorrow, but there's a bunch of new toys in there, and we very, very heavily focus on reliability, safety testing of our products, and basically using the dock. So we're dog fooding our own food, and we are going to invest a lot in both indoor, outdoor test facilities to just get large-scale testing here. So we're 24/7 just flying missions in this place and figuring out rare issues, working on reliability. It's our top focus. So, and then of course, shout out to Multi-Drone. Mark Valentine covered it. I'm going to cover it in the same way, which is to say it's a very exciting part of the future. It's coming. Again, let us know your ideas, but it's obvious. You can parallelize stuff. You can make it faster. It's going to be amazing. So just a quick shout out. Yeah, we have a really talented team that's just working hard on this stuff every day. And we really want to focus on taking state-of-the-art technology, making it work for real use cases, our real products. That's what we're focused on. And I think it's pretty rare. And we have a bunch of people that have done top publications in robotics and conferences around the world. And so we're trying to bring this stuff to bear and pushing forward Skydio's technology and use cases.